All right, in the last lesson, we talked about the volume of a cylinder. So what we're going to do today is look at the volume of cones and see how closely related they actually are. So if you look at activity 1 here with 8.2, we're not actually going to work through this. You could do it on your own if you have some time, but I want you to just kind of visualize what's going on in this experiment that they're talking about. Okay, it says use a paper cup that is shaped like a cone. So right here in this picture on the right. So if you think of kind of like what shaved ice comes in. It says trace the top of the cup on a piece of paper and find the diameter of that circle. So if you were to trace this circular part onto your paper and then measure the distance across it through the center, that would be your diameter. Now, it says use these measurements to draw a net for a cylinder with the same base and same height as the paper cup. So basically what you're doing is you're creating a cylinder like you have here, but the diameter of that circle would be the same as the diameter of the cone that you have. And the heights are both the same also. So you have this cylinder that you've formed. It's basically a can now. And then you have this cone. It's like a shaved ice cone. So here's the experiment part. It says fill the paper cup with rice, or fill it with anything. And then pour the rice into the cylinder. And you're going to repeat that until the cylinder is full. And what I want you to do is I want you to think about how many cones do you think it would take to fill that cylinder up to the top? Now, whenever you put that answer in, the correct answer, if you were to actually do this experiment, would be 3. It would take 3 of these cones to fill the cylinder until it is full. So our last bullet point here says use your result to write a formula for the volume of a cone. So if it takes 3 cones to fill a cylinder, that means that the cone is 1/3 of the size of the cylinder. So if you remember from our last lesson, the volume of a cylinder is pi r squared h, where r was the radius, h was the height. But since a cone is 1/3 of the size, we need to multiply all of that by 1/3, or you could divide it by 3, it would be the same thing. So this right here is your formula for the volume of a cone. So again, you may want to highlight that, circle it, something to where it sticks out. And again, just like with the volume of a cylinder, you will not be given this formula for the test or for the map test, so you're going to have to memorize that. As long as, if you have cylinder memorized and you know that a cone is 1/3 of the size, then it's really easy to remember. So moving on to the next page. Now it says on activity 2, you can remember the volume formulas for prisms, cylinders, pyramids, and cones with just 2 concepts. So for the volume of prisms and cylinders, this is what we talked about the other day. All you did was you took the area of the base and you multiplied it by the height. And that gave us the volume of that prism or cylinder. Now, if we're talking about a pyramid or a cone, if you think back to what we just did, you take the volume of that prism or cylinder and think about how many of those cones fit inside the cylinder. So we would take 1/3 of that volume, since the cone is 1/3 of the size of the cylinder. And it's the same thing with a pyramid and a prism. Now, coming down to activity 3, we're going to be looking at shapes that are what are called oblique. Okay, and right here it says if you think of a stack of paper, if you adjust the stack so that the sides are slanted or oblique, that's all oblique means, is it's been slanted. So if you take this stack of paper and you just slant it a little bit, do you change the volume of that stack? And the answer is no, you do not. You haven't changed anything about it other than the way it's slanted. So if you look at these two cylinders right here, we have a right cylinder straight up and down, has the right angle right there. And even if you just shift it and slant it a little bit, everything still is the same. It would still, the same amount of liquid would still fill that cylinder. So the way you would find the volume of either one of these is the exact same formula, exact same process. Now looking at the next page, they give you examples there of cones also, same concept. So number 4 says, in your own words, how can you find the volume of a cone? So if you think back to what we did with the cone and then filling the cylinder with the rice, we took the area of the base which in a cone and in a cylinder, that's going to be the circle. We found the area of the circle, then multiplied by the height, but then if we just left it at that, that would give us the volume of the cylinder. So we noticed as we poured the rice into the cylinder, it took 3 cones to fill up that cylinder. So our last step that we had to do in finding the volume of a cone is to divide it by 3, which is the same thing as taking 1/3 of that. Now we're going to skip number 5. We've kind of already looked at something like that. And we're going to jump over to the practice page. And I'm going to do 2 of them with you together, and then the remaining of this page will be your assignment. So let's look at number 1. Okay, and keep in mind our formula for the volume of a cone. So here we're finding the volume. So the very first thing I'm going to do is I'm going to write that formula. 1/3 times pi times the radius squared times the height. And again, you're just plugging in numbers wherever they go. So I have 1/3 times pi is 3.14 times, and in this cone, your radius, remember your radius only goes from the center out to the edge. And here they give us the distance all the way across is 12. So your radius is going to be half of that, which would be 6. Still have to square it. And then your height is 4. So we have 1/3 times 3.14 times 6 squared is 36 times 4. And I'm just going to plug all of this straight into my calculator. Now, I'm going to save the 1/3 part for last because all that means is to divide by 3. So we have 3.14 times 36 times 4. And then I'm going to divide all of that by 3. And here you have your answer. And it said round to the nearest 10th. So if I do that, we'll have 150.7. And since it's volume, our labeling would be meters cubed. Okay, so that's how you do the first few, just simply finding the volume of a cone. Now the next one I want to jump down and do is look at number 4. Because here they give you the volume, and you have to find the missing dimension. In this case, we're going to be looking for the height. So, on number 4, they tell you the volume is 300 pi. So again, I'm going to start out with my formula. Volume equals 1/3 times pi r squared h. And I'm just going to plug in all of the numbers that I know. So the volume I know is 300 pi. 1/3. Pi is 3.14. Your radius here is 12. And then the height, we don't know. I'm going to leave that as h. Now, as I start to get the h by itself, one thing that I notice right away was I had a pi on each side. I have a pi over here and a pi over here, which I made 3.14. So if I divide by 3.14 on both sides, that's going to cancel, and it's going to cancel the pi on the left-hand side as well. So we have 300 equals 1/3 times 12 squared is 144 times the height. Okay, the next thing, I'm going to go ahead and simplify this and take 1/3 of 44. So just remember, it's the same thing as taking 144 and dividing it by 3. So that equals 48. So we have 300 equals 48 times the height. And to get that height finally by itself, we're going to divide by 48 on each side. So 300 divided by 48. And you get 6.25. And again, it wanted us to round to the nearest tenth. So that would round to 6.3. Now we're talking about millimeters, and it's just a height. So your labeling would just be straight millimeters. Okay, so you have an example on each section to kind of go by. So your assignment is just to finish the rest of this page, page 174.